So I grew up in a town with 2 national labs and another one that was about 40 minutes away, which is pretty unusual. Had a lot of scientists around me, so I think going into STEM was a natural progression. However, I actually started out as a math major in college and didn't change until about 2 years in. I had a provost, Tom Bond, who really encouraged me to go to graduate school, and I thought to myself, I don't want to go to graduate school in math. So I switched to chemistry. So I actually knew almost nothing about hydrogen when I interviewed here. I knew a little bit about fuel cells from some advanced technology research that Energizer was doing, but I wasn't directly involved, so I had a vague inkling of what a fuel cell was and what it did. But when I came here and visited, I just thought the technology was really interesting. There's a lot of different types of materials involved, metals, polymers, catalyst materials. So a lot of interesting scientific problems, and at the same time, I could see the applications that were broad and not necessarily tied to one industry like fuel cells were at the time, very focused on transportation. So PEM, or proton exchange membrane electrolysis, is you have the core of the device is really the membrane, which can conduct ions, and a catalyst on one side that makes it easier to produce oxygen, and a catalyst on the other side that makes it easier to produce hydrogen. The rest of the cell is basically materials to support that catalyst-coated membrane and to get fluids in and out. So it's all about porosity, thickness, geometry, all those types of things. And so in the electrolyzer, water comes in the oxygen side, is split into oxygen and protons, which go across the membrane and produce hydrogen on the other. I think one of the reasons that it's been so interesting to work in PEM electrolysis is, as I said, there's so many different materials. I have a lot of colleagues and collaborators that work on the fuel cell side, and they said what was exciting to them when they got into fuel cells was that only 20% of the technology was really developed to its full potential, and there's all this work you could still do. And I feel like that's where we are in electrolysis. There's still so many improvements we can make through advancing the manufacturing, understanding the materials better, improving them, looking into new areas, that it still has a lot that we can leverage in terms of the science, manufacturing, and industrialization. So in moving this facility from roughly 50 megawatts to roughly 500, you have to plan the supply chain much more in detail to make sure that you have the materials flowing in as you need them. You also have to figure out how you're going to either scale the processes that you have or develop a different process that has the throughput that you want. And for most of the processes that we've implemented here, they both provide that extra throughput, but also give us higher quality parts so that we're reducing the cost of the stack at the same time. I think the best thing about working with Nel is the people. I've really found it to be a very good culture. I like my colleagues genuinely as people. I think we have very innovative people and people who are very dedicated to the cause. And if you look across the Wallingford facility, there's many people who've been here more than a decade, and it's because they really want to see the company succeed and they want to see their work impact something of value like decarbonization and helping the environment.